Hello everyone. Today we are going to solve the fourth problem of AtCoder beginner contest 338, which is island tour. So what is the problem? We are given in islands and in ridges. So there is an edge between ith island and I plus 1th island, and there is the nth edge between n and 1. Okay, the edges are also bidirectional. Now what is the problem statement? We will be given m islands. Okay, now we have to tour from x1 to x2 to x3 to directly xm, right? So we are given islands, and we have to conduct a tour from x1 to x2, x2 to x3, like that, to xm minus 1 to xm. Now we have to minimize the total number of edges in the path. Now there is also one additional constraint that from the n edges we have to remove exactly one edge, right? We have to remove exactly one edge, and we have to find the minimum number of edges in the path. Okay, so let's take the first example. The first example is that we have three vertices and three edges, so the edges are from 1 to 2, 2 to 3, like that, and 3 to 1. Now the path from x1 x2 xm are like that, from 1 to 3 and 3 to 2. Now let's say we are removing the first edge from 1 to 2. So we are removing the edge from 1 to 2. Okay, if we are removing an edge from 1 to 2, then how we can go from 1 to 3? So there is exactly one edge which connects 1 and 3, so the path will be from 1 to 3. Now we have to go to 3 to 2. Now there is an edge directly connecting 3 to 2, so total number of edges in the path is 2. So we are going from 1 to 3 directly, and from 3 to 2. And now let's say we have first removed this edge. Now let's say we are removing the second edge from 2 to 3. So now we are removing the edge from 2 to 3. Now from 1 to 3 there is still an directly edge, so we are going from 1 to 3 now, but there is no edge from 3 to 2. So how we can reach from 3 to 2? We can directly go to 3 to 1, and from 1 we can go to 2. So there are total 3 edges in the path. Now let's say we are removing the edge from 1 to 3. Now we can't directly go from 1 to 3, right? So we have to go to 1 to 2 and then 2 to 3. Now from for going to 3, from 3 to 2, we can directly take the edge from 3 to 2. So total number of edges in the path is also 3. So we have to find the minimum number of edges in the path, so which is 2. So our answer will be 2. Okay, so here you can see that we can remove every edge and try to try to find the total number of edges in the path. The total time complexity, if we follow this approach, will be order of n square. But if you see the time complexity or the constants, the n is 2 to the 2 into 10 to the power 5. So overall time complexity could be order of n or order of n log n, but we can't solve it in order of n square. So how can we solve the problem, right? So for solving the problem, let's observe some things. So the first observation here is that how we can go from I to j. How we can go from I to j, or the first observation is nothing but the I to j is same. I to j is equivalent to j to I. So total number of edges from I to j is equivalent to total number of edges from j to I. This is the first observation. Then the second observation here is that what are the number of edges? What are the number of edges in the path from I to j? What are the possible paths we can take from to go from I to j? Here we are considering that I is less than j, because we have already told that I to j is similar as j to I. So we are considering only the condition where I is less than j. So for that, what are the two possible paths, right? The one possible path is directly go from I to I plus 1 to I plus 2 to j. So total number of edges in that path will be j minus I. So let's take one example. So for this case, from 1 to 2 and 2 to 3 is the graph. Now for 1 to 3 we can directly go from 1 to 2 and 2 to 3. So total number of edges will be 3 minus 1, which is equals to 2. Now there is another path which goes from I to n and n to j. There is a path from I to n and n to j. Okay, the total number of edges in the path will be nothing but n minus j plus I. Okay, so n minus j plus I. So there is also a path from 1 to 3. The total number of edges are n minus j, which is 3 minus 3 plus 1, which is equals to 1. So this will be 2 and this will be 1. So there are two paths. I hope you get it. So first path is j minus I and the second path is n minus j plus I. Now how we can solve this problem, right? So I will explain my approach to you for now, that how I am solving the problem, right? Now let's say we are removing some edge from I to I plus 1. Let's consider that we are removing some edge from I to I plus 1. Okay, we are removing the edge from I to I plus 1. Now what will happen, right? So there will be some nodes from 1 to I, and there will be some nodes from I plus 1 to n. Okay, now what will happen? Let's say here is one node, let's say k, and here is one node, let's say L. Now we are removing this edge, right? Then we can't take the first path, right? We can't go from K to L directly. So K to K plus 1 to, we can't move in this path. The second path, the second possible path will be to go to L to N and then go to N to K. So this is one path. This path we have to take. So if for two nodes K and L, the second path we have to take. And for any node, let's say let's call it as A and B here, and C and D here, A and B here, and C and D here, we can take the direct path, the first path. For any node in the left region, we can take the first path. This is the first path. And for any node in the right region also, we can take the first path, right? But if any node in the first region and the second node in the second region, we have to take the second path, right? So let's call it the this is the first path and this is the second path. So for any node which is in exact one region, A and B are in left region, so we have to take the first path, and any node which are in the right region, we can take the first path. But if the first node is in the first region and the second node is in the second region, we have to take the second path. I hope you get it. Now how we can calculate this? So when we are removing some edge from I to I plus 1, let's consider that we have something called as prefix of I. Prefix of I will give us all the sum of values of length of the paths from where two nodes are present in the first region, in the left of I. Okay, so prefix I will denote all the possible combinations which are in the left, and suffix of I plus 1 will give us all the first paths, all the sum of length of the first paths in the right region of I plus 1. Okay, so here prefix I will give us all the nodes in the first region, and suffix I plus 1 will be giving us the length of the paths, sum of length of the paths in the second region. Now now there is a case when we have to consider the length of the second paths, right? So how we can do that? So the function is n minus j plus I. Okay, so here you can see that we can get all the sum of k in the left region, we can get all the sum of the sum of k in the left region, and we can take all the sum of n minus l in the second region, and we can store it in some other array. Let's call it prefix 2. Prefix to I will give us summation of k in the left region, and similarly suffix 2 of I plus 1 will give us all the summation of n minus l in the second region. And after that, if we sum all these things, prefix I plus suffix I plus 1 plus prefix to I plus suffix to I plus 1, we will get our desired answer. Okay, I hope you get it. Now I will tell you how we can use prefix I and suffix I directly to solve this problem without involving prefix to I and suffix to I. Okay, so let's jump into my code. So here is my code. So where I am building two vectors, or two adjacency list, you can say. So forward I denotes, let's say we have an edge from I to j. Okay, let's say we have an edge from I to j. We will put I to j in the forward list if I is less than j, right? and we'll put j to I in the backward list, right? Why? Let's say we are having some age from 1 to 3, then for the forward adjacent list of 1, so let's call it as forward of 1. Forward of 1 we will put 3, because we are having some age from 1 to 3 in the forward direction. Now we'll put backward of 3, we'll put 1 in the backward of 3, because we are getting some age from 3 to 1. Okay, so if we have something like xi and xi plus 1, we'll take the minimum of these two and put it into the forward array. Similarly, right, we are taking the minimum of this and putting the maximum of xi and xi plus 1 in the forward array of mini, and similarly we are taking the maximum and putting mini in its backward direction. I hope you get it. Now how we are calculating prefix I and suffix I here. Okay, so let me explain that to you. Now we are first trying to calculate the summation of a minus b in the left region. So so for if, when we are at some node I, we'll try to check what are the nodes present in its backward direction. So we'll take all the nodes which is present in the backward direction. So all the j's which is less than I and present in ith adjacent list will be in backward I. Okay, in backward I. Okay, so we'll take the sum of I minus j. We will be taking the sum of I minus j which is present in backward I. So for all j present in backward I, we will be taking I minus j, right? Now what we are doing in the prefix to I. So what we are trying to do in the prefix of I, we are taking the summation of k. So we are taking summation of k. That means that let's say there is an age from j to I. There was an age from j to I, and in that case we were adding plus I, right? Sorry, we are adding plus j. So when we are at j and there is an age from j to I, we'll be adding plus j in prefix to I, right? So here we have to delete that. So instead of that, we will be adding I minus 2j in our prefix I. Similarly, there will be some ages from I to I plus I to k. Let's say there is an age from I to k where I is less than k. These are forward edges, right? So for that we have to add plus I in the prefix to I. We have to add plus I in the prefix to I. That's why we are doing prefix I plus equals to I into length of forward of I. So all the k's which are present in a forward of I, we have to add the contribution of plus I in the prefix I. I hope you get it. Similarly, we are adding I here, right? So when we are at something, some of those case, so we have to delete this minus j here. I hope you get it. Why we are doing this minus j here? Because this I will be j of some of those k's, right? I hope you get it. So here how we are calculating prefix of I. Similarly, we have to calculate the suffix of I here, right? For calculating suffix of I, we have to take the consideration here also. We have to we'll be doing j minus I, and when we are doing j minus I, we have to subtract n minus j also. So when we are doing j minus I, we have to subtract n minus j also. So this calculating the suffix is quite similar to the calculation of the prefix. You can go through the code, and if you have any doubt in this part, you can ask me in the comment section. I will try to reply that. Okay, what I am doing here, because the video is becoming longer, and this thing prefix of I and suffix of I are quite similar. That's why I am not explaining this. You can go through the code and try to understand. Okay, and for every age from 1 to n, we are trying to remove the nth age, ith age from 1 to n. So that's why we are doing prefix of I plus suffix of I plus 1. Now for the special age, when we are removing the age from n to 1, the answer will be prefix of I, right? Because let's say we are removing 1 to 2, 2 to 3, 3 to 4, and 4 to 1. So when we are removing this age, the calculation will be directly available in prefix of 4. Why? Because we are only going in the forward direction. That's why for the special age, our answer will be prefix of n. I hope you get it, and at the end we are printing our answer. I will provide the link of the code in the description box. If you have any doubt in any part of the explanation, you can always write in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel. Thanks.